Earth's rotation is speeding up, and no one expected it. For most of human history, Earth has felt constant.
The ground beneath our feet seems steady. The sun rises, the stars move, day becomes night, and time feels fixed. Entire civilizations were built on that sense of order. Farming, navigation, religion, science, and eventually modern technology all relied on one quiet assumption:
That Earth spins the way it always has. But what if that is not completely true? In recent years, scientists noticed something strange. Earth, the planet that defines the length of a day, has at times been spinning slightly faster than expected. Not enough for anyone to feel, not enough to change daily life in any obvious way, but enough for the most precise clocks on Earth to detect it, and enough to raise an unsettling question. What happens when the planet begins to outrun the clock? To understand that, we need to begin at the start. Earth rotates because it was born rotating. More than 4.5 billion years ago, the solar system formed from a collapsing cloud of gas and dust. As that cloud shrank, it spun faster. Within that spinning disk, planets formed, and Earth inherited that motion. Once a massive object starts spinning in space, it tends to keep spinning. There is no air in space to slow it down, no brake pressing against the planet. So Earth kept turning. That turning became our day. But Earth's rotation has never been perfectly constant. In fact, early Earth likely spun much faster than it does now. Billions of years ago, a day may have been only a few hours long. Over immense spans of time, the moon gradually slowed Earth's rotation through tidal forces. That same process pushed the moon farther away. So the length of a day has always been changing. Usually, those changes happen so slowly that they are invisible to human life. But not all changes happen over millions of years. Some happen over decades, seasons, or even shorter periods. And that is where the mystery begins. Most people think a day is exactly 24 hours, or 86,400 seconds. But the real Earth is not that neat. The planet's rotation shifts slightly. Some days are a little longer. Some are a little shorter. These changes are tiny, usually measured in milliseconds. For most of history, no one could detect that with precision, but atomic clocks changed everything. Unlike older clocks, atomic clocks measure time using the natural vibrations of atoms, making them incredibly stable and accurate. And what they revealed was surprising. Earth is not a perfect timekeeper. Sometimes the planet rotates a little slower than expected, sometimes a little faster. That creates a strange conflict between two ways of measuring time. One is based on Earth's rotation. The other is based on atomic physics. If Earth rotated perfectly, those two systems would stay aligned forever. But Earth is not perfectly steady, so they slowly drift apart. That matters because the modern world depends on exact timing. GPS, satellites, financial systems, communications networks, and power grids all rely on precise synchronization. Even tiny mismatches can matter. For years, the main concern was that Earth was slowly spinning down. That is why timekeepers occasionally added a leap second to official time. A leap second is exactly what it sounds like: one extra second inserted to keep atomic time aligned with Earth's actual rotation. It is a strange idea. Humanity sometimes has to adjust its clocks because the planet is not following a perfectly even rhythm. But then things got stranger. Instead of only seeing slower rotation, scientists began measuring unusually short days. Earth was, at times, spinning slightly faster. That opened the door to something once considered highly unusual: a negative leap second. Not adding a second, but removing one. In other words, skipping a second to keep civil time aligned with a faster spinning Earth. That sounds tiny, and it is, but the implications are real, because many digital systems are built to handle added seconds more easily than missing ones. A negative leap second would be new territory. So why is this happening? The answer is complicated, because Earth is not a rigid, lifeless ball. It is a dynamic system made of moving layers. The atmosphere shifts, oceans circulate, ice melts and redistributes water, the crust flexes, the mantle moves, the core churns deep below the surface. Whenever mass shifts around a spinning object, its rotation can change. The same principle appears in figure skating. When a skater pulls their arms inward, they spin faster. Move mass closer to the center, and rotation speeds up. Move it outward, and it slows down. Earth responds in similar ways. The atmosphere plays a major role. Winds move enormous amounts of air around the globe, exchanging angular momentum with the solid planet. Seasonal changes in circulation can slightly alter the length of a day. The oceans matter too. Currents move huge volumes of water, and tides redistribute mass constantly. Because water is heavy and mobile, it can subtly affect rotation. Then there is ice. As glaciers and polar ice sheets melt, water shifts into the oceans, changing how Earth's mass is distributed. Over time, even that can influence rotation. And beneath everything lies the deep Earth. The liquid outer core and solid inner core are hidden from view, but their motion may also affect how the planet spins. Some scientists suspect that core processes could help explain part of the recent speed-up. That is what makes this story so fascinating. There may not be one single cause. The answer may involve atmosphere, oceans, ice, core dynamics, and other factors all interacting at once. Earth is not one mechanism. It is many systems talking to each other. And rotation is one of the signals that lets us hear that conversation. There is something deeply humbling about this. We tend to think of time as fixed and universal, but the time we use every day is partly based on a planet that is restless and alive. Days feel perfectly stable only because the changes are so small and our lives are so short. In reality, the day is not a rigid unit. It shifts, it breathes, it wanders by tiny amounts depending on forces ranging from lunar tides to global winds to hidden motion inside the Earth itself. That does not mean disaster. The phrase, "Earth is speeding up," can sound dramatic, but this is not a catastrophe. The average person will never notice these changes directly. The sun is not suddenly rising hours earlier. Life goes on exactly as before. But scientific importance is not measured only by size. Sometimes the most important signals are incredibly small. A tiny wobble in a star can reveal a planet. A tiny shift in light can reveal a distant galaxy. And a tiny change in Earth's rotation can reveal hidden processes shaping the entire planet. That is why scientists care. Rotation is like a global fingerprint. If the planet spins slightly faster or slower, something in the Earth system has changed. The challenge is figuring out what. And that is where real science becomes visible. Science is not just a collection of answers. It is a process of careful measurement, uncertainty, and refinement. Researchers compare data, test models, challenge assumptions, and slowly narrow the possibilities. In this case, the mystery is still open. How much of the recent speed-up is temporary? How much is part of a longer trend? How much comes from atmospheric variability, ocean circulation, climate-driven mass redistribution, or deep Earth processes? And will a negative leap second ever actually be needed? Those questions are still being studied, but maybe that is the most exciting part. Even now, in an age of satellites, supercomputers, and atomic clocks, our own planet can still surprise us. Not with giant explosions or obvious disasters, but with tiny deviations hidden inside the length of a day. That changes how we see the ordinary. A day feels simple. Sunrise, sunset, morning, night. But behind that familiar rhythm is a spinning world born from cosmic dust, shaped by gravity, slowed by the moon, and continuously adjusted by air, water, ice, and molten metal deep below our feet. The clock on the wall looks absolute, but beneath it, is a planet still finding its balance. And maybe that is the deeper lesson here. Science does not make the world less mysterious, it makes it more astonishing. The more precisely we measure reality, the more complexity we uncover. Earth did not suddenly become variable. We simply became precise enough to see the variability that was always there. That means the story is not really about a planet behaving strangely. It is about humanity learning to notice. Every second on a clock represents an agreement between physics and nature, between atomic precision and the motion of a spinning world. When those two drift apart, even slightly, we are reminded that timekeeping is not just a technical system, it is a relationship with the planet itself. So the next time you look at a clock, remember what it hides. Behind every day is a world rotating through space, a world shaped by forces ancient and ongoing, a world that seems stable only because its changes are so subtle we rarely notice them. Earth is still spinning, just as it always has, but not like a machine, like a planet, alive with motion, full of feedback, rich with hidden complexity. And somewhere, in observatories and laboratories around the world, scientists are measuring those tiny changes, trying to understand why the oldest clock humanity has ever known has started ticking just a little differently. Not because the world is ending, but because the world is speaking, and we are finally precise enough to hear it. Earth's changing rotation is a reminder that the universe is not only mysterious in distant galaxies or around black holes. Sometimes the mystery is here, beneath our feet, hidden in the smallest fraction of a second. The more closely we study this planet, the more alive it appears. Not fixed, not silent, but active, responsive, and full of motions we are only beginning to understand. And maybe that is what makes Earth so extraordinary. Not that it is perfectly predictable, but that even now, after centuries of science, it can still surprise us.